Today, I will continue what I started last meeting. I started to talk about rainfall. And the most important terms I covered last meeting, that the rainfall water over the ground surface is called runoff. The amount of this runoff, how much water we can collect, depends on three factors. What is the amount of rainfall? What is the size of the area in which the rainfall lands? And what is the nature of the ground over which the rainfall water flows? And we learned the meaning of this term, runoff. And we talked about hydrologic cycle. And there is a term here which is very important. We have area of land, area of ground surface called drainage area. Just to remind you what is the meaning of drainage area. We have a certain area of land. This certain area of land is served by this channel or canal. So any drop of water over this area only, any drop of rainfall over this area will be collected in this way. The topographic shape of this area of land will allow for each drop of water to flow to this stream, the third name. So we have a channel, canal, or stream. This area of land can be called drainage area. If you have a drop of water here outside this drainage area, believe me, this drop of water will flow in a different direction. So this expression is very important. This term, drainage area, can be called catchment area, sometimes watershed area, or drainage basin. And we can decide this area based on contour map. If you have a map with contour lines, because contour lines means this line of contour, any point on this line has elevation equal to 150. So based on these numbers and these elevations, I can decide the drop of water will flow in this way or this way. Okay. One more thing I covered last meeting is, and I will repeat this question one more time. We have drainage area served by this stream. My question is, do you think once the rainfall starts, 1 second after starting of the rainfall, do you think we can reach the maximum flow, or we can call it peak flow in the stream just after starting the rainfall, or we need to wait a little bit? The answer last meeting, we need to wait a little bit. How long we need to wait? Is it 10 minutes, 15 minutes, 1 hour, 2 hours, 3 hours? I will explain it in more details. If you have a drop of water here in this point will take 3 minutes to reach to the stream. If you have another drop of water here, it will need 10 minutes to reach to the stream. If you have another point here, we'll need around 20 minutes to reach to the stream. Point here will need 12. Point here will need 13. Point there will need 5 minutes. The longest time, the farthest path. Can you see these two expressions? Longest time or the farthest point. We have here, this is the farthest point. This is the longest time. So after 20 minutes of starting the rainfall, we can reach the peak discharge in the stream. This time is critical for us. We can call it concentration time. Concentration time or time of concentration, whatever, TC. This time is very important, very critical, because after this time, the discharge in the stream will be maximum, will be peak. We have a term today which we call the time of concentration. Time of concentration is the amount of time needed for runoff to flow from the most hydraulically remote point in the drainage basin, in the drainage area, to the point of analysis, which is the stream. So, for example, we have a point here. This is the farthest point, or this drop of water will need the longest time to reach to the stream, or the point of analysis, which is the start point of stream. The path or route taken by the most remote drop is called hydraulic path. So this way or this line of bathing will be called hydraulic path. The hydraulic path might not cover the greatest distance, probably not the greatest distance, but the greatest time, the longest time, compared to the routes of all other drops in the drainage basin. Hydraulic path for a typical drainage basin initially runoff travels over overland flow, shallow concentrated flow, and stream flow. We will cover this later, but at this time, we need to figure out the time of concentration, which is the longest time for any drop of water to reach to the point of analysis or the start point of the stream. In a different way, this time of concentration, 20 minutes, means after the start of the rainfall, by 20 minutes, the discharge in the stream will be maximum. That makes sense? Any questions so far? If you have any question, let me know. We need to, in this meeting today, we need to understand two things. What is the concept of time of concentration? And then how to calculate this time. That's all. We don't need anything else. So we understand right now the meaning of time of concentration. One more time. After the start of the rainfall by 20 minutes, or I'm sorry, after the start of rainfall by this time, which is time of concentration, the peak discharge will be in the stream. The path between the location of the drop point and the point of analysis or the start point of the stream, we can divide this path to 3 parts. From A to B, then from B to C, or first one looks like this, second one looks like this, Third one looks like this. So 3 parts, part number 1, part number 2, and then part number 3 in the stream. Or part number 1, part number 2, and part number 3. For any cases, the point to reach to the point of analysis, we have 3 different parts. The first part or the first travel over land flow. The second one shallow concentrated flow. The third one called stream flow. I can say, or I can explain it in one more time. After just the drop to reach the ground surface, we can see this shape of flow over the ground surface. Then the water will be collected to form something here which called small rivulets. Small rivulets. You know, if you are watching, I believe, in your street around your house, here is the street. I believe during the rainfall, we have a line here at the midpoint of the street. This water will flow in this direction, and any water on the other side will flow in this direction. Then the water will be collected by here, gutter or something like this, in this direction and this direction. And finally, we will have this location to collect the water from this flow. So this one can be called small rivulets. This one can be called overland flow. This one. And finally, collecting here, we will have pipe to collect the water coming for this area. So this one can be called stream flow. So the sequence of collecting rainwater or rainfall, we have 3 sequences. The first one called overland flow is usually the first type of flow as the drop starts from the remotest point. Just the drop reach to the ground surface and start to flow. The second one called shallow concentrated flow occurs when the natural indentations of terrain cause the runoff to form into small rivulets. The third one, all water collected in the stream flow. So we have 3 parts. If you would like to calculate the time of concentration, you have to calculate the time for each part. The first one, it is overland flow. It is characterized by sheet flow down, a relatively featureless slope similar to the manner in which water flows across pavement. This is the slowest of all type of flow. I believe the flow here will be very slow. Typically, overland flow cannot travel more than 100 feet before consolidating into a more concentrated flow. What is the time T1 during this trip, overland flow? To figure out this one, we need to determine how long the the strip length. The second one, what is the type of ground? The third one, what is the slope? Then I can tell you what is the time required for this part of flow. We are going to use this chart. The first scale here, which called length in feet of the strip length. So I will say, hey, here is the start point of the drop. This drop will flow this distance L as over land flow. So for example, 50 feet. Then I will put here at 50. So the first step, what is the strip length of this flow over land flow? The second one, what is the type of ground? We have many types here. Dense grass, average grass surface, poor grass surface, bar soil, or paved surface. So you need to determine the rainfall is coming on a paved surface or soil or grass surface, and what is the degree of this grass? Is it poor, average, or dense? For example, we are on paved surface. Okay, let's choose another one, not paved. Okay, poor grass surface. We have grass, but it's very poor. Go ahead and draw a line between the strip length and the type of surface and extend this line. So we are done with the strip length. We are done with the type of ground surface. The next step, what is the slope of the surface? What is the slope of the ground surface? Do you have slope? Yes, we have. How much? 2%. For example, 2%. I will put here the percentage or percent slope. From this point, which is pivot line, to this slope, I will draw another line and extend it. The extended line will reach here to 8.5 minutes. This is the time T1. So if you have drop of water flowing over poor grass surface, and this surface of area has a slope 2%, believe me, this drop of water will need 8.5 minutes to reach here. That makes sense? One more time. I would like to repeat it one more time. Let's assume you are in your street and the length between this point and this point is 150 feet. And you are watching a drop of water at this location. And the slope of the street equal 1.5%. Can you tell me how long time will it take for this drop of water to reach to this location? We have this chart to tell you this information. Let's start. What is the length of the strip? 100 feet. So go ahead on the first scale and put 100 feet. 20, 40, 60, 80. So 100 feet will be here. Something here. 150. And you are talking here about your street. The street is paved, I think, paved surface. So you have here paved surface. Go ahead and draw a line between this point and extend it. Will intersect here. The slope of this street is 1.5%. So the next step, what is the slope? You said 1.5, so 1.5 will be here. 1.5. Go ahead and draw another line between this point and this point. This line will intersect with this scale at 7.5 minutes. So any drop of water at this location will need 7.5 minutes to reach or to flow to this location. That makes sense? During this area of land, we have overland flow, which looks like this flow. After this area, we will find small rivulets will be created. So we have another type of flow, which is called shallow concentrated flow. Before going through shallow concentrated flow, any question so far? Guys, do you have any question so far? Okay, so right now, after the overland flow, we have small rivulets, which called more concentrated flow. Shallow concentrated flow occurs when the natural indentations of terrain cause the runoff to form into small rivulets. So before all of these studies, we have to figure out what is the shape of terrain. What is the shape of the ground surface, which is surveying. We need to do surveying to figure out what's going on with the elevation of each point on the street or area or city or something. Okay, so since the rivulets are more concentrated, the flow efficiency is increased. We can expect faster flow, and therefore the velocity is also increased. That makes sense. I think, yeah, when the rainfall will be more concentrated, we can expect more velocity. Time of shallow concentrated flow is determined by empirical nomograph, which is this one. We have another chart. This chart will help us to figure out the time T2. T2 is the time needed for this type of flow, shallow concentrated flow. Based on the surface type, we have only here two types, paved or unpaved. So if your surface is grass, is soil, so we are in the unpaved floor. If you have asphalt layer, so we are in the paved surface. And what is the slope? What is the slope of the ground surface? Based on the slope, for example, 5%, and I go horizontally, and your surface is unpaved, I will go down to figure out the velocity of flow. Your velocity of flow is determined, for example, 4 feet per second. I'm not looking for velocity. I don't care about the velocity of the flow. My concern, how long? Okay. Based on this velocity and the shallow concentrated flow length, how long it will take to reach or to finish up this flow, divide this length by this velocity from this chart, I can figure out the time T2. For example, let's do an example. I told you we have here 100 feet when the drop of water started from here to reach to this point, this one called over land flow. And we found T1 previously. Then the water, because the terrain or the ground surface make this, the water will be concentrated in this way to flow in this small rivulets. For example, it will flow in this shape by 200 feet, another 200 feet or 300, whatever. And the slope of flow here is 2%. And the surface, the ground surface here is paved. We have asphalt layer or concrete layer or whatever. What is the time needed for this water to reach from this start point to this end point? Okay, you said what is the slope? What is the slope here? I told you it's 2%. Okay, where is the 2%? Here you go, 2%, 0.02. You said it's a paved surface, so I will go horizontally until reaching the paved line. So here, this one. Then I will go down. The velocity will be around 3. So velocity will be 3 feet per second. Believe me, the water flowing in this part will have velocity equal 3 feet per second. I don't care about the velocity. What is the time? The time equal the length of this flow, which is 200 feet, divide this velocity that you did it, which is 3. Then the final will be, remember, this distance in feet, this velocity in feet per second. So the final answer, 200 divided 3, will be 66.67 seconds. Please convert it to minute. It will be 1.11 minute. So we need only 1 minute, 0.11 for this flow to start from this end of the previous flow to this end point. After this flow, we can expect stream or river or whatever, something bigger and bigger. To explain it here in more details, guys, we have area. The water on this small area will be concentrated. We have another area, will be concentrated. We have another area, concentrated. We have another area, concentrated. Finally, all of them will reach to the mainstream. You know what I mean? So in this, during this area is called over land flow. Something looks like this flow. Then the flow will concentrate it through this small rivulet. So we have shallow, concentrated flow. Then once the water reaching to the stream, we have something called stream flow. This part of flow has time T1, this part has time T2, this part of flow has time T3. How can I figure out the time T3, which called stream flow. It's very easy. We can figure out the velocity first. Once you get the velocity, I can tell you the time T3 by stream flow length, divide velocity, I can get the time T3. How can I get the velocity? Very simple. Velocity equal Manning equation. K divide N, hydraulic radius to power 2/3, slope to power 1/2, because this is flow. Which called open channel flow. It's a stream flow. So we can use Manning equation to figure out the velocity. Once you get the velocity, what is the length of the stream? Divide velocity, I can figure out the time T3. Okay, we have right now T3, T1, and T2. We are looking for what is the time of concentration. The time of concentration finally will be T1 plus T2 plus T3, because the first objective we need to figure out. If you have drop of water here, and this drop of water would like to reach to the analysis point, which is on the stream. So the time T of concentration Tc equal T1 plus T2 plus T3 to figure out the time of concentration. So finally, Tc, which is time of concentration, equal T1 plus T2 plus T3. It's very important to remember that not all drainage basins have the same three types of flow. Sometimes we have T1 and T2 only. Sometimes we have T1 and T3 probably. It depends on the ground surface. Okay, so later we will see some basins have no stream but may have pavement, pipes, or drainage ditches. So right now in this meeting, we can understand what is the meaning of time of concentration. Time of concentration flow means we have three types probably. Overland flow, shallow concentrated flow, stream flow. Each type of flow has a time. If you add all of these times together, we can figure out the time of concentration Tc. I will solve this example with you, which is the only question in your homework. I will go through this solution right now. So compute the time of concentration, or the concentration time Tc, for 25-year storm for a drainage basin located in Pennsylvania and having the following parameter. This area of land has three types of flow, and the problem saying this. The first flow, which is called overland flow, the area is average grass surface with length 100 feet and the slope 2%. Can you tell me what is the time of concentration, or what is the time for this part of flow, T1? Yes, I can. I will open my note, go back to the overland flow, which is this one. I will delete any previous information, and let's read. The length is 100 feet. Okay, 100 feet, I'm here. And the ground surface is average grass surface. Average grass surface, we are here. Can you draw a line between the 2 points? Yes, I can. We have another point here. The following step, the slope of this area of land is 2%. 2%. So the slope here is 2%. There you go. I will draw another line between this pivot line and this point and extend it. I will reach to this scale. How much? What is the reading? This one is 10. 11, 12, 13, 14, 15. So 11, 12, it will be 12.2. So your time will be 12.2 minutes. I am done with the first type of flow. Very easy. Very easy. The second one. The second part of the flow, shallow concentrated flow. So I will open my note for shallow concentrated flow. This one. Let's start. What is the slope? 4%. And it's not given here what is the type of surface. So if not given, I will assume it's unpaved. So we have 4%. Here you go, 4%. I will go horizontally to hit the unpaved curve. I will go down to figure out here the velocity. Your velocity looks like 3.2. So the velocity equal 3.2 feet per second. But I'm not looking for velocity. I'm looking for what is the time t2. The time t2 will be the length of this flow, 750. Divide the velocity, 3.2. And remember, and keep it in your mind, this one in feet, this one in feet per second. So your answer will be in second. How much? 750 divided 3.2. It will be 234.3 seconds. Convert it to minute. It will be 3.9 minutes. That makes sense? The third flow, which is stream flow. Okay, we need to figure out the velocity by using many coefficient k divide n r h to power 2/3 s to power 1/2. Many coefficient is not given, so I will assume it, for example, 0.013, 0.014, 0.015. That's fine. K equal 1.486. I'm sorry, 1.468. What is the hydraulic radius? We have a cross section here. That's fine. The water surface as a depth 3 feet. What is the area? 6 plus 12 divide 2 times 3. 6 plus 12 divide 2 times 3. What is the weighted perimeter? Hey guys, I'm sorry, I have a mistake here. Main coefficient is given here, 0.032. Okay, the weighted perimeter. Can you tell me what is the weighted perimeter? This length plus this one plus this one. So how much? I think this little distance will be 3. This one will be 3. So this one will be 3 square plus 3 square under square root. It will be 4.24. And this one will be 4.24. So the weighted parameter will be 4.24 plus 6 plus 4.24. Your answer will be 14.4. So the weighted parameter, I'm sorry, the hydraulic radius will be area, which is 27, divide 14.4, 1.875. So 1.875 to power 2/3. What is the slope? 0.4%. So divide 100 to power 1/2. So your final answer will be 4.4 feet per second. I'm not looking for velocity. I'm looking for what is the time T3 for the third type of flow. The time T3 equal the length of this flow, 100 feet, divide this velocity, and remember this one in feet, this one in feet per second. So your final answer will be in second. Remember this information. 227.2 seconds. I will convert it to minute. 3.78 minutes. So the final conclusion is TC equal T1 plus T2 plus T3. T1, how long? 12.2 minutes. T2, how long? 3.9 minutes. T3, how long? 3.78 minutes. So the final time of concentration will be 19.88 minutes. Almost 20 minutes. So guys, the meaning of this time of concentration is, for this area of land in Pennsylvania, under this information, the maximum or the peak runoff, which is maximum flow, will occur after 20 minutes of starting of rainfall. After 20 minutes of the rainfall starting, the peak will reach. So time of concentration is very important. We are going to use this time in our design. This is the only problem in your homework.